Hi guys, today we are going to continue on talking about domain. This time we're going to do domain graphically using interval notation. So remember, domain represents the x values. So here is where my graph starts, where x is -3, and it goes all the way to where x is 3. Notice I did a dashed line at -3 because of the open circle. That matters when we do our interval notation. So this is what it looks like, -3 to 2. Now notice parenthesis versus bracket. The parenthesis is because it is an open circle, so we don't include it, and the bracket is a closed circle, so we do the 2. I do want to do the range as well to remind you. The range is from the bottom to the top. So our range is from the lowest point, which is -2, to the highest point, which is 3. Okay, and again, we're still going to do a parenthesis for the -2 because of the open circle. We're not including it, and a closed circle for that guy. So we are going to move on to this one. So this is a quadratic function. We're hopefully pretty familiar with these, and this one I couldn't get so well, but these arrows are going to be continuing on forever. So the domain of a quadratic is actually everything. It's all real numbers because, change that. It's going to continue on forever in both directions. We could extend this x-axis forever and ever and ever, and this parabola will just keep opening up and opening up. So when the domain is everything, right, -infinity to +infinity, parenthesis always on infinity, and the -infinity always comes first. Now the range on this guy is your possible y values. So here's where my graph stops. So it's everything from -4, so here's y is -4, and up. So our range is going to be from -4 all the way to infinity. And notice I have a bracket on -4 because there was a graph there. It was not an open circle at all. Okay, here's our next graph. This is a square root function. And just like the other one, this one is going to continue on forever. So our domain here is from where we start, this 5, and further. Notice the graph never touches any numbers that are smaller than 5. X is 4, nope, no graph, so it cannot be in our domain. So our domain goes from 5 and forward. So our domain is 5 to infinity. And our range is the y values. Notice we're never in the negative, never in the negative. So our y values are from where y is 0, so this is where y equals 0. And it's going to be all the way to infinity because the square root is going to keep going to all the y values. It's just very, very slowly. Our next example here. Okay, this is an exponential function. And just like the other ones, we have arrow here. Now, what's tricky about exponentials is that this function is never actually going to touch the x-axis, okay? So that's going to affect our range. However, our domain, we're going to continue going on and on and on and on forever. So any negative x values will work. And we're going to continue going on and on and on and on over here. So our domain for an exponential is just -infinity. That range, the y value, like I just said, we're never actually going to touch 0. We're going to get very, very, very close to 0. So I'm going to use a parenthesis to say we don't ever actually touch 0, but we get really, really close to it. And our y values are going to get very large. So there is our range for exponential. Okay, now these are the fun ones. I think I have 2 more examples. These are called inverse variation, but notice there's a gap in the graph, and that actually affects our domain quite a bit. So if you can imagine this break in the graph right here, that's called your vertical asymptote. So the graph actually is going to jump -3 here. So how we write the domain for these type of functions is you're going to say x can be everything over here, so -infinity to -3. we're going to get really close to -3, but we're never actually going to touch it. We have to jump over it. So I'm going to do an open parenthesis to show that we don't actually touch it. And then we're going to use this union symbol. So this interval is the left-hand side of the graph, and now we're going to do the right-hand side of the graph. So we're going to say this graph is going to be everything from -3 all the way to positive infinity. So -3 to positive infinity. That's a little messy. Let me write it down over here as well. So the left-hand side of the graph, I'll do green, is going to be -infinity to -3. And then you want to jump over -3 and go -3 to positive infinity. Isn't that kind of funny? Like it's a break in the graph, so you have to jump over that -3. All parentheses there. And the final example is similar. But look, there's 2 jumps. Holy cow. That means you're going to have lots and lots of these guys. So we're going to start by saying, where are those jumps? Right here at -3 and at 1. That's where the graphs break. So our domain is going to go from -infinity to -3. That's this first section. Then we'll jump it. We're going to jump that -3. So now we're going to do the middle section. We're going to go -3 to 1. That's the middle section. Middle section. Then we're going to jump again, and we're going to do the bottom section, which is 1 to infinity. Whoa, 3 different sections of the graph, 3 different intervals. Okay, so I want you to try this on your Delta Math.